All right, it is 9 o'clock and we are going to get started. Good morning, everyone. Welcome to our December CAD webinar. This is something we tried to hold every month to kind of cover ORD topics. And for the month of December, we didn't really have any solid topics that we wanted to talk about, so we solicited the end users for specific topics that they would like to, see and for us to present on. And I wanted to just say thank you to anybody that submitted those topics to us. We actually met and went through those, and there was a lot of good topics. And we selected a few of those. There was actually more than what we could cover in an hour session. So please know that we are going to keep those and possibly do one of those in a future webinar. So just a quick note, we are recording this and we will be posting this to our wiki page after the webinar, so you can go back and rewatch this if you like. There's also other webinars up there available as well. So the topics that we've kind of selected today was cross-section featuring and editing of name boundaries. Those seem like those keep coming up quite a bit, and so we wanted to touch on these specifically. One of the things that we're looking at changing up is the monthly status of our CAD webinars. We're talking about moving these to a bi-monthly webinar in 2021, with the first webinar being in February. And one of the first topics that we are going to cover is undergrad utilities. That seems like that's something that's been coming up more and more for us. So just look for that at some time in February. We'll be sending invites out for that. Some up and coming training that we have scheduled. We have ORD survey training scheduled for January 12th and 13th. That is currently full. And then we also, because that did fill up so quickly, we actually scheduled a second one for January 26th and 27th. Those will be held virtually using Teams. And I do believe we have some seats remaining in that second one. So if you're a surveyor, we do have that available, and you can self-enroll in the ODOT Learn application. We're also working on a MicroStation Connect Fundamentals training class. This has come up for like new hires and TCEs that are coming on board that, currently don't maybe use MicroStation in any capacity. So we actually met early last week and discussed this, and we're going to be formulating an agenda. And we're tentatively looking at putting that out sometime in February. This will be something that we also do virtually using Teams. This probably won't come from our office. I believe this will be sent out through either the capital programs administrators or the design engineers. We're just going to formulate the email and then forward it on, and then they'll be sending that out to the staff as far as like any new hires and TCEs. We're also looking at doing some refreshers as well sometime during the next year, so you can look for that as well. And then I just wanted to note that we do make all of our online training content available through our wiki page. We've been trying to post everything there, any type of supplemental videos, training guides. It's just a general training resource for our office, along with all the CAD webinars that we record here as well. So you can find those recordings out there. So that's all I had to open it up. We do have Eric Thomas that's going to present, but I don't see him online yet, so I'm going to skip over to Matt Iben. I'm going to let him take over.
All right, thanks, Mark. I'll share my screen. Okay, so we're we're going to punt a little bit. And I was going to go with the second half of this, but I really didn't have any bullet points or any, a whole bunch of slides to add here. But what I was going to talk about was one of the topics, as Mark mentioned, was how to modify or edit your cross-section name boundaries. For example, as you see on this screenshot here, through this intersection. So, in Geopack days, we would have called those pattern lines and ORD, name boundaries. In this case, we're just looking at the plan view. And for the screenshots or, through the demo here, you'll see I changed the colors of those. That was just with some level symbology overrides. But so don't expect to see those unless you change them yourself as well. But anyway, the idea here was how do we modify the name boundaries after we've already sort of laid them out to create our cross-section sheets. So, one thought would be if you're able to think ahead and do these or create these or modify them as you're creating them with the name boundary tools, just by modifying some of the parameters, that's one way. But I think we all know that that's probably not going to happen. Things change. You're going to have to modify them anyway. So as you see here, the main line of this roadway, the red lines intersect the two ramps here. So the idea is, how do we modify those, any of these to accommodate these cross sections so that maybe your end area earthwork calculations come out more accurate. So I have a couple of screenshots here. One thought you could do is just modify the red to meet the blue and the yellow. That gives you sort of an uneven section as you're looking through the set. So I'm not sure, that may be desirable in some cases. Other folks may find that that's not as desirable. I've seen this option quite a few times. And in fact, in a lot of the projects that I had worked on, this was kind of the idea, is we would follow the through road edge of pavement, and that's where we would sort of put our match line for any ramps or side roads or whatever the case might have been. The problem here is that you can see there's a wedge or a triangle there at the intersection itself on each one of these that would sort of get left out of any earthwork calculations. And usually that's probably not too big of a deal. It's probably within some tolerance that's allowable. But probably what would be more preferred in this case, here you'll see I drew in using the name boundaries by two, or cross section by 2 points name boundary command. I drew in an additional name boundary that, in this case, I did some construction lines and I offset it essentially 50 feet from the main line road there. So I think I talk about it in my demo here that's coming up. You would need to identify that on your cross section if you showed a skewed section. Make sure that you identify what that skew is. So those are just some options. I'm not saying one way is better than the other, but as you see here in the video that's coming up, the process to edit the boundaries is kind of the same, regardless of which way you want to approach it. Okay, so now I just want to go ahead and demo modifying a couple of these name boundaries just so we can look at what happens when we do it. In my view here, I have a plan view with the name boundaries, the 3D references attached for the boundaries themselves, as well as in my 3D view, we can see the name boundaries. And in both of these instances, I went ahead and just used some level symbology overrides to change the color of these name boundaries just so we could see them easier for the demo here. And then in my bottom view here, I have a drawing model that I created of a cross section at station 125. And I have that open so that we can see as soon as we change this boundary, the cross section will also be updated as well. And okay, so I'll just modify that view a little bit. Okay, so when we hover over a name boundary just with our cursor, we'll see the little prompt comes up that tells us which boundary we're on, which level it's on and such. So I want to go ahead and I want to do station 125. And when I select on this, I'm going to get the handles or the grips that MicroStation has for the elements. And when I hover over one of these grips, it's telling me which number it is. So there's 4 here, and I'm on the 4th one. And then I can use the Alt key, and when I press that, it's going to preserve the angle on or off. So I think if I select on this right now, that angle is locked. So it's keeping the 90-degree rectangle there. But if I tap on the Alt key, you can see now that that angle is no longer locked, and I can click out here. Now, because they're in a 3D view, I'm really not going to advise modifying these graphically, especially in this way without that angle being preserved. You're not exactly sure where you're going to be clicking. It may look like you're clicking or data pointing out there and getting the right station or snapping to an element, but it may be off a little bit, or it may even be the wrong elevation. And you're probably not going to get what you want here. If you wanted to do it graphically, I would definitely recommend keeping that, preserving that lock, and perhaps you could snap to the other name boundary you wanted to intersect. But in general, what I found is even better is to use Civil AccuDraw, and that's really what I'm going to recommend here. So in my plan view here, you can do this any way you want, as I showed in some of the screenshots earlier. Some people like to see kind of the match line or along the edge of pavement as if it were going through the intersection. You may have some other ways to do it. You may just want to have it extend to the next cross section. And in this case, what I did is I drew in some name boundaries that were 50 feet offset from the center line of this main line here. And I drew those in by cross sections by 2 points, or a name boundary by 2 points. So now they're not perpendicular, obviously, to the center line. So when you did those sections on the ramp sections there, you would need to identify that so that we knew that. But that way, at least captures all of the earthwork that you might need by by the end area methods. So what I'm going to do is I'm going to pull back station 125, and I'm going to have it intersect both of the blue line and the yellow line on left and right. So in my 3D view, I'll go ahead and select station 125. And I'm going to go ahead and modify that, but I'm going to turn on my Civil AccuDraw here. And if you've ever worked with Civil AccuDraw in your plan or your profile, you'll see that this toolbar is now, because I'm in the 3D view, sort of a combination of both of those. So I have my station and offset lock, and I also have my Z lock. And that's what I'm going to use here. So I'll select my point. But we'll notice that none of those values are changing on my heads up prompt. So I need to tap the O key and to select the origin or reference element. Before I do that, though, I'm going to reset here. And when I snap to the top or at the bottom, I'm just going to do the top in this case. You can see at the bottom of my screen, I'm getting the X, Y, and the Z value for these boundaries. And some of these I've already played with as I tested this, but the top boundary is not always at a nice even elevation. And you'll see that when you cut your sections. This particular one looked like that was put in right at 1205. But this other one I'm snapping to right now is at 1207.16, which that's just the way the software does it. So you'll want to, the reason I'm pointing that out is you're going to want to take note of the elevation that you want the top of this boundary to be at, whether you're trying to match exactly what was already created or you want to change that elevation. So at 125 here, my Z elevation is 1205. What I'm going to do, though, is I'm going to change that to like 1208, just so you can see what happens in the drawing model here. So, all right, so now I'll go back. I'm going to go ahead and start to modify this. And now I need to tap my O key to select my reference element. I don't have that attached in my 3D view here, or at least visible. So I'm going to use my 2D view, and I'm going to select that here. And I lost the I lost the command, or it reset the command on me, but that's okay. We can still see that it's set the reference element there, and I can see my station and offset values as well as my elevation changing. So now what I'll do is I'm going to key in 125 plus 0, 0, and I know that I want that at a 50-foot offset because that's what I set these other name boundaries based off of. If you had some other offset or it wasn't constant, or you're trying to match these other ones that were perpendicular, you'd probably just want to just measure off the offset value that you would want at that point. And like I said, I'm going to make this elevation at 1208. And now when I data point to accept this, you'll see both the name boundary change and the clipping of the cross-section change, as well as we'll see the name boundary now be a little bit higher than the grid that's shown. Oops, I clicked on the wrong view. Let me try that again. Okay, so now we see that the cross-section is clipped now to the 50-foot offset that I entered, and I did a 1208 offset, so you'll see that the name boundary now is actually drawn in at 1208. So if you needed to change it along that axis to have maybe you had a label or something that is no longer appearing, or you needed to add some height there, you could do that. And then I can do the same thing on the right-hand side, and then what I'll do is I'll just pull that elevation back down when I do this. So I want 50 feet on the right. I want it at 1205. And we'll see that cross-section is clipped. Then from there, what you can do is, I'm not going to show how to do all of those. It's the same process over and over again. And then we can come in and you can just use your any of your drawing production commands or just general MicroStation text commands, and we can label this as a match line. However you might typically do that on your particular sheets. So that's how you would edit it, a name boundary for a cross-section. Okay, just a couple other things here. You probably noticed that as we were doing this, the name boundary in the 3D view was changing. You may not have noticed, just the way I had zoomed in, that the name boundary also in 2D is changing, but really that's just a reference of that 3D view. So you'll be able to see that. What I do want to do here is just show that if I change the height of this particular section, like I had started with changing the elevation to 1208, and we'll see that that boundary has changed here. If we were to re-annotate this drawing model, turn that off. So I remove my annotations, my match line labels stayed. But if I were to re-annotate this, my new grid would be drawn to that new elevation. So if you have a cross-section grid that maybe you're not really liking, that it's at some weird elevation, you want to change that, that could be one way to edit it, although it would be a bit tedious to go through an entire project and do a whole bunch of sections that way. And then what you'll see if I go to that sheet model, then for 125 plus 0, 0, that boundary is also changed and moved, but you'll notice the difference, or the distance between the two grids has changed. So you'll want to keep that in mind, that if you adjust that too high, you may end up with overlapping cross sections on your view. But again, if you needed additional annotations, or maybe you needed to add some depth to your section to get some existing utilities in, that could be one way to modify the view there, so that you can do that, or adjust that name boundary so you can get the correct clipping to show the section appropriately. Okay, so let's just assume that that we adjusted this bottom boundary or this bottom grid, and now it overlapped the middle section there. We could simply come in and select the reference that we want to move. So each section is a separate reference attachment from the drawing models. So we could select probably the top two if we wanted to move them both together, or I could just maybe move the middle one up slightly. So I could do that and just move that reference however I want. You could use Wacky Draw or any of the other key ends, or however you like to make those sort of manipulations to modify that sheet. Okay, so one more just quick video on rather than editing the name boundary after they were created, I show how to sort of edit this or edit the name boundaries as we create them. Hopefully that in some scenarios, maybe that'll save some time rather than coming back to edit those. Okay, so now I just want to go ahead and demo modifying a couple of these name boundaries just so we can look at what happens when we do it. In my view here, I have a plan view with the name boundaries, the 3D ref. Sorry, that's wrong. All right, so in this demo, I'm going to look at another way to edit your name boundaries, except rather than edit them after they've been placed, I'm going to edit them as I'm placing them. And the scenario that I'm sort of thinking about here is if you need to show or split your cross section, maybe because your section is too wide to fit on one sheet. You want to split it to show maybe the left side on one sheet and then the right on the other. And maybe you're going to use the center line as a match line, or maybe overlap 10 or 15 feet across the center line on each side. You can do that. A lot of times this is done when you have sections with deep cuts and fills, or even some interstate projects where you have a really wide pavement section and a lot of grading that might be going on the outsides or of the sections there. So let's take a look here. So I'm going to start by going to the name boundary tool, and I'll set that to my civil cross section element. And I'm going to use the 5 scale sections here, but in all likelihood, you're probably going to go ahead and make sure that a 10 scale section would probably work first before you split a 5 scale sheet up. Or even you may have to split the 10 scales in half as well. So that'll be up to you to decide. Again, just for the sake of the demo, this is what I'm going to use here. And then I'm going to select my path, which is my center line. And in this sample that I already used, I already have a group that is named State Route 149, so that it went ahead and bumped it up to 150. So what I want to do is I'm just going to make this 149, and I'm going to say it's this is on the left side. And now my start location, I'm going to make this at 120 plus 0, 0. And then my end, I'm just going to do a couple sections here at 122 plus 0, 0. And now here's where I'm going to make some edits to what's typically selected from the drawing sheet here. Is I'm going to go ahead and modify my left offset to be 135, and then my right is going to be 10. So I'll have 10 feet of it right at the center line rather than just having the match line right at the center lines. And that can be whatever you need to make it to make your project work, or whatever you desire there. And just for the sake of time, I'll just say we'll cut that at 50 feet. So then I'll go ahead and give it a couple more data points, and you'll see that my name boundaries are starting to be placed. I haven't finished yet. I did want to point out I have a create drawing toggled off because I don't necessarily want to create these sheets just yet. You could create them as you cut the boundaries, or we could wait. We could place the boundaries and then create all the sheets at once. So I'll go ahead and data point and accept those then. So now my boundaries are placed, and you see those in our 3D view. And now I'll come back and I'm going to create another new group, and this time I'm going to call it the right side, and then I'm going to swap these values here. So this will be -10, 135. Oops, when I select my center line, that defaults back. So 149, right? And then I'll do 120, 0, and 122, 0. And again, I'll swap those values. So it's -10 now and 135 on the right. And I'll leave my interval the same. And again, create drawing is toggled off. So now I have a name boundary on both the left side and right side of my center line. And as I sort of mentioned earlier, you can see the height difference here and how the software determines the top elevation of the name boundary. So when I snap to the one that was created on the right, it's at a elevation of 1202.14. And if I snap to the one for the left, it's at 1200.12. So you may decide you want to try and make those all the same so that each sheet matches. That probably could be an enhancement to the software that we could submit to make sure that that's that works the same. So, and then on the lower end, it looks like for the most part that would probably be the same. So I'd say in most cases you're going to be okay, unless one side or the other might have some deeper cuts or fills or that kind of thing. And then to create your sheets, and I'm not going to do it here, I'm going to open the name boundary dialog. And in my cross-section groups, you'll see I have the SR 149 left and the SR 149 right name boundary groups. And what you can do then is select all of these sheets that you want to create, and then you'll toggle on the show create drawing dialog, and then lastly click on the create cross-section drawing. And that'll bring up the same dialog that if we would have toggled that create drawing on previously, that would have been here. And then as you finish this, you would have the same options that you normally would as far as naming your sheets and whether you want them all in one DGN or in separate DGNs, and then all your drawing and your sheet model options there. So hopefully that's helpful in maybe some of those situations where you need to modify something. Or maybe you're at an intersection like we were showing before and you want to go ahead and create your boundaries such that you can accommodate that intersection in a situation like this. Okay, that was all I had, Mark. Not sure.
Okay.
If Eric has joined us.
Yeah, he's online now, so he should be up next.
Great.
Eric, you there?
I am. Can you hear me?
Yep, we got you.
Sorry, I joined in a little late.
No, that's all right.
I had 9:30 in my brain for some reason. So,
okay.
We go ahead and share screen here. All right, you should see the opening PowerPoint slide. Have you got that?
Yep, we see it.
Okay. Not to take away from Matt, but I just want to clarify the top of the boundary. When you're clipping your sections and you pick the drawing seed, it defaults to 10 clearance on the top and 10 on the bottom, so that the bottom clearance, for some reason, Bentley rounds that to an even, but they don't do that with the top. So it's just looking at the model and what's the highest thing within the boundary and going 10 feet above. So that's why it ends at an odd station. And I know that's been talked about with Bentley to maybe have that round up to the increment of your scale, but I don't know if that has any traction with Bentley for them to change that. But that's what's happening. It's just finding the highest element in the model for that particular name boundary, adding 10 feet to that, and that's what determines that elevation for the top. So a little sidebar there. So this was some open requests, and we had some requests from a user who was doing some cross sections, but they only had a few sections, and they wanted to put in some existing items, but they weren't necessarily going to be processing templates or modeling. So I want to talk a little bit about displaying some existing items on your cross sections, specifically pavement and right-of-way lines, construction limits. They had a couple questions about that in the guardrail. I'm not going to talk about utilities specifically, telephone lines, gas lines, etc. I think JD wanted to cover that in a separate webinar in the future, so I'm going to stay away from that. So we'll take a look at that, and then I'll take a look at a couple of tips for manually drawing on the cross sections. So that's what I'm going to cover. So just a little background here. You know, if it's going to show up in a cross section, it must be in the 3D model. So whatever the name boundary intersects, if it's a 3D object in a 3D model, it's going to show that on the cross section. And they don't all have to be in the same file, right? They can be in different files and referenced together. So the name boundary intersects that 3D object, it's going to draw it on the cross section. Now, for just things that are just lines, like a right-of-way line, there's no volume to that or depth to that. It's just a single line. So what it does is it displays a cell for that, the way ODOT has the standards configured. So linear elements can show up on the cross section, and we'll dig into that a little bit, how that's handled. So first thing that the user asked about was existing pavement, and it's really two different approaches to showing the existing pavement. You can do it with a corridor template for your existing pavement, or you can apply a template to a terrain surface. And both of these methods were discussed in our first CAD webinar. So I'm not going to revisit that. What I want to do is just point you towards where that information can be found. So there's an example of just 2 layers of existing pavement on a cross section. This was generated by making a terrain model using the edge of pavement, center of pavement, and edge pavement, and just making that as its own little terrain, and then applying a template to it that had the pavement depth defined. So that can be reviewed from ODOT's wiki page. So in the open roads environment, the workflow, there's that Ohio DOT workflow, and JD added a bunch of links. So there's a link to take you to the wiki page, and then on the wiki page you'll find some training resources and the webinars. So that first webinar has some widening and resurfacing information, and then towards the end of that presentation it covers the existing pavement. So I'm going to refer you back to that initial webinar for information on putting that on your cross sections. Now, right-of-way and construction limits can be displayed. Like I said, it requires a geometry element, and it does require that that element has a profile defined. And then once you define a profile for that element, it creates a 3D linear element in the 3D model of that right-of-way file. So there is information on doing that in ODOT's Open Roads training material. So I will refer you back to that. But I want to dig a little deeper in this. The question was, well, here's where the training material can be found. So back on that wiki page under training guides, there's a chapter for right-of-way stuff on the design training. So that's got, towards the end of that chapter, information on assigning a profile to the right-of-way lines. Now that information shows, I guess I'm getting ahead of myself here. So anyway, it tells you that, the name boundary intersects that 3D line, then it's going to place a cell, and the cell's defined in our annotation group. So the next video kind of digs a little bit into the annotation group. But before I go to that video, in this particular case, the user was asking, well, what happens if my right-of-way is outside the limits of my terrain model? Because the training material says just open up a profile view for the right-of-way line and assign the existing ground as the active profile. That gives it an elevation and makes that 3D element. If you're outside the terrain model, you don't have that existing ground to do that. So this video should go over, it's either this video or the next one will go over some of that. I think the first one talks about the annotation options. So let me go ahead and run that video. Let's take a quick look at how our annotation for our cross section is defined. So what I have open is a container file for my cross sections, and I've attached some references. I have my survey attached, I have my center line, and I have a right-of-way file that just has one right-of-way line in there. And that right-of-way has been defined as a 3D element by opening the profile view for that and assigning the existing ground terrain as the active profile. So that creates that 3D element in the right-of-way file, and I can see over here in my 3D view the 3D line that's created from that. So let's take a look at our annotation definition and how this is annotated. So when my name boundary intersects this line, it's going to do some annotation. So in the Explorer dialog, Open Road Standards, I'm going to look at the libraries and annotation groups. So I'll expand annotation groups, and it shows me any DGN libraries that are defined in our standards. So this is in the feature definition DGN lib. If I expand that, you can see there's annotation groups for plan, profile, and cross section. And looking at cross section for our drawing model, there's two different items, one for 5 scale cross section annotation and a 10 scale. So I'll select the 5 scale. And in the properties dialog, I can see the settings here. So there's an annotation list, and it tells me the values vary. So I'll click in that field, and I get a little button that I can choose to review the settings. So here are all the different items that are currently configured to be annotated. So if our name boundary intersects any of these items, it's going to do some annotation. So I'm just going to look at right-of-way. So we've got some proposed right-of-way items defined, and we've got our existing right-of-way items defined. And this is our existing right-of-way fee line. So I'll select that item. So what it's doing, it's looking at the location definition here, and the way we have that defined is we're looking at all the points that the name boundary may intersect, and if its feature definition is linear right-of-way RWX right-of-way line fee, then it's going to go annotate something. So I'll close that. Well, if it finds that feature definition, it's going to annotate it with a cell. There's no leader line. The placement is there's no offsets or rotation, so it's right at the intersection of the element, and it's going to place the cell RWX fee. So that's just a quick overview of how these are defined in the annotation definition. And if the name boundary intersects that particular, in the case of a right-of-way line, that particular feature definition, it's going to place the cell. So the question was, what if my right-of-way is outside the limits of the terrain model? So the 3D right-of-way line, you know, if the right-of-way is outside, obviously I can't create a profile from the existing ground. But a profile for the right-of-way lines can also be defined similar to any other proposed element. So I've got the next video is going to talk about the profile from surface and quick profile from surface, and then also profile by slope from element, and how those commands can be used to potentially define that elevation for the right-of-way line. So whatever elevation it's defined at, when it places that cell on the cross section in the drawing model, that's the elevation it's going to use to place that cell. Let's take a look at a few different options to define a profile for our right-of-way lines. So our training material covers the process to open a profile window for a right-of-way line and use the existing ground terrain as the active profile. And that works well when the right-of-way lines are contained within the limits of the terrain model. In this particular example, at the end, my right-of-way line on the left runs outside the limits of my terrain model. So I would have a section that would not have a profile defined, and then a cross-section at this station would not have a 3D element to find and annotate that right-of-way line location. So what I'm going to do is use the existing ground profile and then add a little bit of profile here and create a new profile for that. So I'm going to start by opening a profile view. So I'll just use my element selection tool, select my right-of-way line from its pop-up menu, open a profile model. I'm going to show this in view 3, so I'll open view 3 and just click in that view to display the profile. If I zoom out just a bit, I can see this shaded region corresponds to the length of my selected element, and I can see that gap at the end where it runs out of existing ground. So there's some limits to what I can do with this ground line, but I can use it to make a new profile or a complex profile by just drawing in an element here and joining those together. Now, if I only needed a portion of this, I can't trim this element or partial delete this element. So if I needed to do that, what I would do is under the profile creation tools, I would either use profile from surface or quick profile from surface. Profile from surface allows me to define limits to that. At the beginning and the end, I can define a start distance and end distance. And the other one, the quick profile, just goes for the entire length, and it doesn't give you those options to define starting and ending distance or offsets or any of that. If I use this option, it's basically the same thing as what I've done here to show the profile. The difference is it's a new element that I could use microstation commands to partial delete that element. So I'm not going to use either one of those. What I'm going to do is just draw in a line. So I'll use the line between points, and I'm just going to come off the end of this element and put in a line. So I'm going to let it AccuSnap lock into the end of that and just enter that length to lock that in. And I do have AccuDraw open, so I can lock to that slope of 0%, or I could come over and type in 0%, enter that, and that would lock that in. So I'll go ahead and accept that to place that line. So I'm going to use these two pieces to make a complex profile. So I'll just use my complex geometry here, select the beginning of the ground line, and let it automatically complex those together. So this is a new element. It's not using the actual ground line element. It has made a new element on level default for that. And the reason it's on level default, the feature definition I currently have active, this right-of-way X right-of-way fee line does not have a profile symbology defined. It's something we could add if we needed to, but this isn't going to be used for anything else. So it's probably not that critical. What I want to do is just select that element and set that as the active profile, and that will make my 3D line string for that going to full length using this new piece. So I'm going to close that out, and let's take a look at the other side. For this one, I'm going to assume that I did not have any terrain. So what I want to do is define a profile for this, and what I'm going to do is just do a profile by I didn't mean to pause that. Slope from element coming off the profile at a slope of 0%, and it'll just match my centerline profile. So in my profile tools under element profiles, we'll find the profile by slope from element command, and it's asked me to locate my first element to profile. So I'll select this right-of-way line and then reset to complete my selection. Locate the reference element. So we're going to come off the center line, a slope of 0, and I'm just going to accept the rest of the defaults here. I'm not going to adjust the profiles, no vertical offsets. So that makes a profile, the slope from this element, and sets that as the active profile. So the last thing I'll do is just hold down my right mouse button. From view control, I'm going to open my views, two views, plan in 3D. Just take a look at my 3D model just to verify that I've got those 3D line strings for those elements. And I can see that I have those elements drawn in the file, and I can see that this one does indeed go for the entire length to the end of my new line that I drew. Let's take a look at a few different options to define a profile for our right-of-way lines. So our training material covers the... Okay, I didn't mean to start that again. So this is another video just showing how those lines come in on the cross sections. So let me go ahead and roll this one. Here's a quick look at the annotation for the right-of-way lines. So I'm at station 170, and on the left I can see that that's annotated just above the ground since it was following the existing ground profile. And on the right I can see that's annotated in relation to the existing ground profile. I didn't have a proposed profile defined. So that's why it's floating up in the air. So you can move that in the drawing model. So if I go to the drawing model for station 170 and move over to this one, I can just use a microstation move command and grab that and just slide that down a bit. So going back to my sheet,
And now that's falling just above the ground instead of floating in the air. So that's some of the cleanup work you may need to do if you're defining a profile for just from a proposed profile instead of reading the existing ground. And just to look at the ending stations, here's my sheet for 172 plus 50. So I can see that's following that profile that I drew out there, and now it's following again the profile offset.
Okay, so hopefully that gives you a couple ideas of what you can do if you need to put some elements in that are annotated with a cell. And again, they're just coming in at, whatever the elevation is defined for those profiles. Okay, so the user also asked about guardrail on cross sections, and they were specifically asking about existing guardrail. And just like the right-of-way lines, it does require a geometry element with a profile defined, because this is going to be placing a cell. So if it intersects that 3D guardrail line, it's going to place a cell in the cross section. And then that again is defined in the cross-section annotation group is where that's defined. So I had the annotation groups open earlier, and there are some guardrail items defined in the annotation groups. You'll notice that same with our feature definitions. In our standards, we have feature definitions for the proposed guardrail, but we don't have feature definitions defined for existing guardrail. They are defined as survey definitions, but not as geometry, just linear points that could be used. So in this current release, I can't really automate the placement of existing guardrail if you needed to do that. And I'm probably getting a little ahead of myself here. In the next release, Bentley has added the ability to for the cross-section annotation to find survey features. And then I could place text or a cell if I find a survey feature. So we could define some things for existing things based off the survey features. So right now there's no existing guardrail items defined in the feature definitions or existing guardrail in the annotation groups for the cross-sections. So if you do need to show some existing guardrail in a cross section, and I've got a couple tips for you here for drawing in some things on the cross sections. So yeah, there's that, what I just said. The next version, 10.9, adds the ability for us to annotate survey features, and that will allow us to define annotations for existing releases. So right now in current 10.8 versions, if we need to place guardrail, we need to do that manually. Okay, so just a little review. Of course, we know each cross-section is displayed in its own drawing model. And within the drawing model, the grid is placed as part of that annotation definition. So our zero offset is at the x0 coordinate on the cross-section, and our y values are placed at their actual elevation. So that's going to allow us to easily draw on the cross-sections using MicroStation and using AccuDraw without any need for any special tools. So those of you with a GeoPack background, remember there were some tools in GeoPack that were used for drawing on cross sections, and that was because it had to be related to the cross section cell. They weren't drawn at their actual elevations. That cell could be anywhere in the file, but in OpenRoads, since they're each in their own model, they're each at that zero offset and the actual y value. So here's a video just kind of talking about some tips for drawing on cross sections.
Well, let's take a look at just a few different tips for drawing on our cross sections. And to do this, I'm going to use AccuDraw to assist. So just remember that AccuDraw and Civil AccuDraw cannot be both used at the same time. So you're using one or the other. And I have AccuDraw open. So just to get started, I'm in a drawing model for one of my cross sections, and just want to review the location of the grid in the model. It's drawn at its actual coordinates. So this zero offset point is drawn at my x value of 0, and then my elevation here, 585, is the actual elevation. So I can verify that by just issuing a tentative point to snap to the beginning of this line. So it's 2 buttons at once on the line, and it went to the nearest key point since key point snap is active. And I can see the coordinates for that point are 0 and 585, which corresponds to my grid location. So that means I can enter things at X and Y coordinates using AccuDraw. And as I move my mouse, you can see it's tracking my cursor position. To the left, my X value is negative, and then to the right, my X values are positive, and then the elevations are corresponding to the actual elevations of my cross section. So I'm going to place an existing guardrail cell. So I'm on the Open Roads Modeling Workflow on the Drawing tab, and here's my Place Cell command. So I'll go ahead and choose that command, and I can see the guardrail left XXS is my active cell, and it's dragging on my cursor. So if I know an offset and elevation value for that, I can go ahead and type those in. Maybe it's 14 feet to the left, and it's at elevation 604, and that's going to put that at that elevation. Now, I may not know the elevation, so let me show you another option using an origin, setting an origin with AccuDraw. So in AccuDraw, I'm going to type the O key, which is to set an origin, and I can see nothing's happening. Okay, so the shortcuts for AccuDraw and Civil AccuDraw are shared. So by default, in an Open Roads installation, the definition of the O shortcut is set for Civil AccuDraw. And I can review that by just doing with AccuDraw window active, typing in a question mark, and it'll bring up my keyboard shortcuts. And I can see for O, which is my set origin, it's running a Civil coordinate set origin command, and that's a Civil AccuDraw command. I wanted to run the AccuDraw set origin. So what I'm going to do is add a couple of child commands for that O shortcut. So I can do that by selecting the shortcut and in the top picking Add Child. And it's going to tell me, hey, if you do this, you're going to remove the shortcut that's defined. So I'm going to go ahead and say, yeah, let's do that. And it takes that shortcut off. So I'm going to add 2 shortcuts, one for AccuDraw. So I'll just use an A for that and hit Tab. And this will be for AccuDraw. And I'll give it the command of AccuDraw set origin, all one word for set origin. I'm going to add another child to my key in for O, and this will be for Civil AccuDraw. So I'll use a C, and I'll give it a label of Civil AccuDraw. And we'll put in that Civil Chord set origin command. So I'm going to go ahead and apply this change and then close the dialog. So the way this works is wherever my cursor is located, if I type in the letter O, it's going to ask me, do you want to run this command for AccuDraw or Civil AccuDraw? And then it's going to set an origin. Well, that was the last data point I entered or something. I'm not sure why it went down there. But if I snap to my grid point here, type in O, and hit AccuDraw, it's going to put the origin right on there. Now, this is just a one-time origin. It's not a permanent origin. So for every command that I run, I'm going to have to set that origin for the command. So for example, I'm going to go back to my Place Cell command, and it's floating on my cursor, and I'm going to snap to my grid origin and type O and choose AccuDraw. And now relative to that point, I can define the X location, and I'll use a -14. And it's going to lock that value in. And then for the Y location, I'm just going to come up and zoom in a bit and just put it approximately on the ground line there. So that's an example of placing some cells, couple little tricks with AccuDraw and defining an origin for that. The other thing I want to do is just show you placing a line. So, you set your level, color, style, and weight and all that stuff. And I'm just going to use a place line command. Of course, I've got the same thing. AccuDraw is tracking my position. So if that were 15 feet to the right at elevation 603.25 or something, that's the beginning of my line. And from there, I could put in a second point with an X and Y coordinate, or if I wanted to use a delta key in, just a microstation key in field, DL equals delta, whatever I'm going to go from there, I could do that type of thing. So I'm not going to go into any more detail than that. I just wanted to give you some information to get started and let you know that you can draw on the cross sections, and that they are drawn at their coordinate locations. So that's very convenient to allow you to use an AccuDraw and some other tools to put those elements in your file.
So that's all I've got. So hopefully there's a couple things that are helpful there, a couple tips, especially that origin thing with AccuDraw. That was something I wasn't aware of and had to look that up. You guys have any questions on any of that? Okay, if there's not any questions, I'm going to turn it back over to Mark.
All right, thanks, Eric. So we only had one question in the chat. Looks like Matt answered that. And we're right at 10 o'clock. So if there's no more questions, we will go ahead and end the webinar. And as I mentioned before, look for that future webinar probably sometime in February, and it will be covering underground utilities for that upcoming webinar. So thank you again for attending today, and we'll hang around for a few minutes if there is any questions that come in. Otherwise, have a great day. Thank you.